Hello everyone, in this tutorial we're going to study about some chemical element, continue with another video. So the first is we have an explanation of some dot of the notice of the chemical element. So one chemical element is distracted into some part that is the explanation to explain the part of it. So it is a complex element, chemical element. So the first thought they say an amine sulfate usually amine. Amine, the sulfate usually is amine. For example, methylamine, ethylamine. So the sulfate, the end name of it is amine. Also amine, the same. The root name can be penylamine as an analog of methylamine or the systematic benzenamine in practice. The EU-PAC accepted name is aniline. So there is uh, the the peculiar of the penylamine is EU-PAC accepted as aniline. Penyl is the side chain of benzene bound with amine, and amine is an H2, but ammoniac is an H3. So amine is an H2, penylamine is penyl bound with amine, NH2. Uh, Analog of methylamine and the systematic is benzenamine. So systematic of the chemical element of penylamine is benzenamine, and methylamine is methyl and amine at the end. So methyl there are one carbon and one carbon or CH3 and H2. So EU-PAC name is quite opposite of benzenamine or penylamine. The ring is numbered from the point of attachment of the amino group. So when we gonna to numbering the aniline, it is not as what we would desire, but it is the principle that we should obey. They say that we must number amine, the first amine of the functional group amino with number 1, and then we can count the size of it 2, 3, 4, 5, 6. If it is aniline, there are 6 carbon or there are 6 number that we can number it. The prefix ortho, meta, and para are widely used to denote 1, 2, 1, 3, or 1, 4. So what does it mean when we saw the word O slash O O minus M minus or para minus? So there is the derivation of ortho. So ortho is the full form of O minus. O minus is the abbreviation, or O minus is the abbreviation form of ortho, which means carbon 1 and carbon 2. If they are the substituent at carbon 1 and carbon 2, we name it ortho as the prefix. Meta also count carbon 1 and carbon 3, and it is the abbreviation of meta M. And P minus is the abbreviation of para minus. So para is the substituent of carbon 1 and carbon 4 arrangement respectively, which means the arrangement is respectively according to the number 1, 2, 1, 3, 1, 4. So 1 substituted with 2 auto, 1 substituted with 3 is meta, and 1 substituted with 4 is para. So start with 1. On an aromatic ring, and it is only contained in the aromatic ring, but another ring does not contain automata para, such as the cyclic ring, which there are no double bond alternatively. So as we see the pictures below, it is the chemical element that have multiple functional group. So OCH3, we can identify it as methoxy, and there are two methoxy functional groups. So we call it D-methoxy, D which means 2. And OH or HO is the functional group of alcohol or alcohol. So there are also two functional group of alcohol. Yes. And what does we name this chemical element? So we name it 2, which means the alkane or alcohol at the straight chain, at the zigzag chain. It have the side chain of it is the benzene bind with another functional group, which as we call later. So we name it 2, which means pennyl is at carbon 2. 3, hydroxy, which means HO is at OH is hydroxy at carbon 3 in the benzene ring. Minus 4,5 D-methoxypenyl. So if there are two methoxy as the functional group, we just number it accordingly. 4,5 and 2 is D. Methoxy is OCH3. Penyl, which means the benzene ring, is the substituent of another chemical element. And butanol is the zigzag chain above, which means there are 4 carbons of alcohol. So alcohol is alkane plus OH. So next is we see the chemical element is also the same, but they are different in number of numbering it. So it is not aniline, but we can identify it because it is familiar to aniline. We can name it like the first of the zigzag of alcohol is 1, 2, 3, 1, 2, 3, 4. Or 1, 2, and the reflection of it is 1 or 2. 1, 2. So 2 is in the middle, and it is also the side chain of the hydroxy butyl dimethoxypenyl. So I'm going to explain it again. 5, which means dimethoxypenyl is at the substituent of alcohol at carbon 5. 1 hydroxy, which means hydroxy is at carbon 1. The first that we saw is hydroxy is at carbon 3, but this is the different numbering. Butyl is there are 4 carbons at methyl, 4 carbon methyl, which means butyl. 2, 3, which means methoxy is at carbon 2 and carbon 3. We number 2, 3 accordingly. And dimethoxypenyl. This could be named. So the first dot is they explain about it. This could be named as an alcohol or as a penyl. So we can name it as alcohol or penyl. When we name it alcohol, we just systematically call it, and the last is alcohol. Or if we call penol, which means benzene bind with OH, penol. As an alcohol, butanol, yeah, we just call the count the carbon, the number of carbon, make a propyl, and add the sulfate ol. So butanol. There is a substituent pennyl ring attached at position 2. So pennyl is attached at substitution 2 of the alcohol. So they name it 2, 2. So 2 or 5. But in this picture, they counted 5. So 1, 2, we call the longest chain. 1, 2, 1, 2, 3, 4, 5. The 4 is omitted. The 6 is also omitted. The one that we see is the one that has a substituent. So they write it in the picture. Note the pennyl and its substituent are bracketed to keep them together. Okay. So the substituent are bracketed to keep them together. We saw it 1 hydroxy by 2 il as the 3 functional group of the hydroxy by 2 il. So it is the alkane or butanol group. Okay, so let's skip to the fourth dot. As the penol, the substituted butane side chain is attached through its 2 positions, so has a root name butyl to show the position of attachment again. Butyl is butanol, and the root name of it is butyl, which means its 2 position, and il is alkyl as the substituent. This is the bracket to separate its numbering from that of the penol. Oh, I see. So alcohol is in the bracket because it has 1 functional group, and dimethoxypenol is outside the bracket because it is the longest chain, and to not rewrite it to so that we will not confuse about it. And the last dot is D3, tetra, etc. are not part of the alphabetical sequence for substitution. D-methoxy comes under M, whereas 3-hydroxy comes under H, etc. So D3 tetra is not the part of alphabetical sequence. So alphabetical is not. It is just the prefix to add when there are 2 substituents at the same functional group. When does we call D? D is 2 functional group the same. 3 is 3 functional group the same. Tetra is 4 functional group at the same, and etc. So 1 does not have the prefix. Whereas 3-hydroxy would come under H. So dimethoxy comes under M, and 3-hydroxy comes under H, etc. So that's all for now for this tutorial. I hope you guys would gain an insight about some chemical element and about chemistry organic. See you next time.